Okay, so the first part of this unit is solving trig equations. We've done very simple ones where if you look at the ones we've done, all of the trig ratios are already isolated. So what makes them more difficult or more elaborate is the equations are not set up in the same way. There's more to do. Okay, and you have to think about is sine of theta is kind of like x. You want to isolate it so that we can solve for it. Okay, so in this case, let's take 3 sine theta to the other side. So it'll cancel out there. So you'd have 2 sine theta. And then let's take this 2 to the other side like so. And then we'll divide by 2. So sine theta is negative 1/2. And now you have the trig ratio by itself. You have it isolated and we can solve. So sine is negative here and here. The reference angle is going to be pi by 6. So this means theta would be 7 pi by 6 in quadrant 3 and 11 pi by 6 in quadrant 4. Again, if you don't have these values memorized, how did I get 7 pi by 6? This is pi plus pi by 6. This is 2 pi take away pi by 6. Okay? So we've got a few more questions like this to do. You don't need to show the steps. You can do it mentally. If we subtract cos from both sides, you're going to get 2 cos on that side. And if I add 1 to both sides, I'm going to get 2. I'll divide by 2. So cosine is 1. Where is cosine 1? Right there. So the reference angle is 0. So theta is 0. And not 360, because we're doing radians, 0 and 2 pi. Okay, next ones are in degrees, so we'll do a few of those. Again, we need to isolate, so I'll subtract 2 from both sides. So where is tan? 0. Here and here. The reference angle is 0 degrees. And so you're going to get 0, 180, and 360. Okay, I'll subtract 4 sine from both sides, so I get 2 sine theta plus root 3 is 0. Then I'll move that root 3 over and divide by 2. So sine is negative here and here. The reference angle will be, I think we're still in degrees, so it's going to be 60 degrees. So theta is 240 and 300. Okay. Now we'll get a little bit more difficult with the squared. All right, and I'm going to suggest one way to do this. I don't like doing this, but for the first little while it might make it easier. Let's replace tan with x. So I'm going to say let x be tan theta. If you don't say that, you're introducing a variable and you'll actually lose a half a mark. So make sure you do that. So instead of tan, I'm going to put an x. Now, if you saw this question, this is a grade 11 question, you could factor it. Okay, it's x minus 4 and x minus 1. And so you would have 2 solutions. What's going to make it 0? Well, x is 4 and x is 1. But remember what x is. X is tan. So this means that tan of theta is 4 and tan of theta is 1. And now this should look familiar. Tan is positive here and here. Let's figure out what the reference radians, so be careful about that. Okay, so I'm going to put in 4. And I get a reference angle of 1.326. Okay, so let's, just for space-wise, I'm going to write them vertically. So in the first quadrant, you would have 1.326. In the third quadrant, you would just add pi to that, and you're going to get 4.467. Okay, then let's go to this one. Where is tan equal to 1? Well, it's positive here, and this is actually an exact value. I know this is pi by 4. So I'm going to put pi by 4 and 5 pi by 4. There are my 4 answers. Okay? So you can do the same thing here. You can let x be cos theta, but I'm okay if we factor it this way. So I'm sine theta, that gives me cos squared. And then I'm going to put minus 2 plus 1. If you figure that out, that's the correct factors. So this tells me cosine theta minus 2 equals 0, and cosine theta plus 1 equals 0. So cosine is 2, and cosine is negative 1. So cosine is 2, positive here and here, but I see this is greater than 1, so there will actually be no answer there. Cosine is negative 1 here. The reference angle is 0, but I don't really need that because I know that this is pi. Okay. So let's do this one with let x. Again, you don't need to do this. Some people like it better. It's up to you. And I'm going to bring the 1 over. So let's factor. So I get 3x and 2x. I need a plus 1 there and a minus 1 there. So this gives me 2 solutions. X is 1/3 and negative 1/2. So I'm going to have cosine theta is 1/3. Cosine theta is negative 1/2. Okay. This one is not an exact value, so I'm going to need the calculator. I get 1.231. So let's write those answers down. 1.231. And then to get the second angle, so that's this one, the second angle, I'm going to go 2 pi, take away that value, and I end up with 5.052. Do this one. I recognize that this is an exact value. Where is cosine equal to 1/2? It's at pi by 3. So I'm going to have 2 pi by 3 and 4 pi by 3. Okay, we'll do one more set here for today's lesson. Let's just put it into degrees. So factor it first. This one's a little bit of a different one. I only see 2 terms. It's not a trinomial, so I'm not going to factor it like a trinomial. Hopefully you see there's a common factor. If I factor out a cosine, I end up with cosine plus 1. And that means I get cosine equal or cosine plus 1 equal to 0, right? This factor is here. So where is cosine equal to 0? It's going to be here and here. And where is cosine equal to negative 1? That's here. So what's my reference angle? My reference angle here is 90 degrees. My reference angle here is 0 degrees. So I get 90, 270, and 180. Does it matter what order you write them in? It doesn't. It's nice if you do them in order, but you don't have to. Okay, I'm going to factor this one without using let x. You are welcome to use let x. All right, what is going to work here? How about -2 there, -5 there? I think that works. That's -4, -5. Yeah, that works. So I have 2 tan theta minus 5 equals 0, and tan theta minus 2 equals 0. So tan theta is 5/2. Tan theta is 2. Tan is positive here and here. This is not an exact value, so I'm going to grab the calculator. Make sure that you're in degrees. So this is 68 degrees. So let's write those in. I'm going to have 68 degrees and 248. Where is tan positive 2? Here and here. That is also not an exact value. And this one is 63 degrees. So I'm going to have 63 and 243. Okay, last one we will do today, I believe, yeah. Last one we'll do today. Well, that looks a little bit different to factor, right? If you notice, this is not a trinomial. Okay, how am I going to do this? How am I going to factor this? Well, before you do any factoring, it might be worth it to let's look at it in terms of x. So if we had 2x squared minus 1 equals 0, how would you factor that? Well, you actually might use your perfect squares. If you remember solving using perfect squares, you isolate the square. So I'll write it like this. And then if I divide by 2, I get x squared is 1/2. And if I want x, I'm going to take the square root of 1/2 and remember to put plus or minus. This means that sine theta is plus or minus. Well, have you ever seen root 1/2? Well, this is the same as saying plus or minus. The root of 1 is just 1 over root 2. This is actually the same as plus or minus root 2/2. These are all the same. Okay? So where is sine positive or negative? That means we're going to have 4 answers because we have the positive value and the negative value. Where is sine root 2/2 or 1/2? That's at pi by 4. Oh wait, that's in degrees. We're better go 45 degrees. So this answer will be 45 degrees, 135, 225, and 315. Okay? So you can now do exercises 5 to 8 from the handout, but there's also some textbook ones you can give a shot at. Okay? So there's your homework.